So in a balanced chemical equation, we have a recipe for how to make the products. So we're going to look at this simple one. Hydrogen and nitrogen react to form ammonia. What type of reaction is this? Synthesis or combination, because we've got two reactants in one product, ammonia. Okay, so we have the pictures here as well. We see that 3 hydrogen molecules react with 1 nitrogen molecule, and that's going to make 2 ammonia molecules, right? Just like with the pictures in the pancakes. So we can write conversion factors from this chemical equation just like we did from the recipe for the pancakes. What if I wanted moles of hydrogen to moles of ammonia? Well, how many molecules? Those 3 molecules. Moles is just a multiple of that, right? So 3 moles of hydrogen would give me how many moles of ammonia? 2. It's just the number, the coefficient.
Would it be wrong to say 6 individual hydrogen atoms?
Would it be wrong to say 6 individual hydrogen atoms? There are 6 hydrogen atoms, but we generally deal with moles because nothing that is large enough to see can be really counted. And we typically are interested in the moles of whatever the formula is rather than the individual atoms. But it would be 6 moles of hydrogen atoms, but they're coming as molecules.
So if it's diatomic, you generally just leave it?
Mm-hmm. Yeah. What if I wanted to know the ratio of moles of nitrogen to moles of hydrogen? So what number do I put here for moles of nitrogen? 1. And for hydrogen? 3. So I put the units here. If the noise in the hallway bothers you, feel free to close the door. In front of nitrogen is an understood 1. In front of hydrogen is a 3. Okay? So we have these conversion factors hiding in the balanced chemical equation. Everybody okay with that? So if we had 3 moles of nitrogen and more than enough hydrogen, how much ammonia can we make? This is like if we had 8 eggs, how many pancakes? Well, this is one because the numbers are nice. You can kind of do it in your head. He's like, well, this has one nitrogen in it, but we've got 3. So I've got 3 times as much as what's specified, and so it's going to be 6. But we should be able to write this out. So 3 moles of nitrogen. I'm trying to find moles of ammonia. So moles of NH3. I want to divide by moles of nitrogen to make the unit go away. Put the units in first and then get the numbers. The units tell us where to put the numbers. So for nitrogen, it's 1. And for ammonia, it's 2. And so I can make 6 moles of ammonia from 3 moles of nitrogen. Everybody okay with that? How many moles of nitrogen would be needed to completely react with 7.13 moles of hydrogen? Okay, now we don't have a nice whole number anymore. Well, write down the number. I've got 7.13 moles of hydrogen. And the question is asking me how many moles of nitrogen would I need? So I want to find moles of nitrogen. And I'm going to divide by moles of hydrogen because I want those units to cancel out. Put the units in place. Get them to work out. then look at the equation. So I've got moles of nitrogen. It's 1 mole of nitrogen that reacts with 3 moles of hydrogen. This time I have to use a calculator. 7.13 times 1 divided by 3. I got the 3 from here. 3 moles of hydrogen react with 1 mole of nitrogen. Just like 1 cup of flour is needed for every 2 eggs. My calculator is showing me this. .38 moles of nitrogen. These mole ratios that we're making here, these are exact because they go back to 3 molecules of hydrogen reacting with 1 molecule of nitrogen to make 2 molecules of ammonia. That is exact because it's individual particles coming apart, going back together. Any questions? Yes?
Will we always be given a formula to find the conversion?
You mean, will you always be given the chemical equation?
Yeah.
Not necessarily. Because we've already learned how to predict products and balance equations, right? So on a test, I prefer to separate things into individual steps. But on the worksheets, all bets are off. I'm sure there's some questions on worksheet 8 where they give you the reactants and they give you a mass or a number of moles, and you have to predict the products, write the equation, balance it, and then do a problem like this. It's good for you.
Is it?
It is, yeah. Getting stronger hurts, right? It hurts. No pain, no gain. Sorry. Okay, so let's look at an example here. Water forms when hydrogen gas reacts explosively with oxygen gas according to the balanced chemical equation. So here we're given the equation. And it says, how many moles of water result from the complete reaction of 24.6 moles of oxygen? Assume that there's more than enough hydrogen. That's like the fine print. I like to use the balanced chemical equation to organize the numbers, right? So I look at the number that I'm being given, 24.6 moles of what? Of oxygen. So I'm going to write this under oxygen. 24.6 moles. Now I don't have to write O2 because I wrote the amount under O2, I know what it is. Then I look at what's the question. Well, here's the question word, how many moles of water? So I'm going to put a question mark under H2O, and the unit it's asking for is moles. How many moles of that? Everybody okay with that? So I can go from moles of anything in this equation to moles of anything else in the equation in one step. I don't have to go moles of oxygen to moles of hydrogen to moles of water. I can jump between any two. So it's always one step from moles to moles like this. So my path is moles of oxygen to moles of water. So 24.6 moles of oxygen. I have one arrow, I've got one converting factor. I've got moles of water there, and then I'm going to put moles of oxygen down here. Those cancel out. Use the formulas that are given in the equation. So I need numbers here. I get them from the balanced chemical equation, from the coefficients. In front of O2, there is no number. I understand that to mean 1. So I'm going to write a 1 there. In front of H2O is the number 2. So I'm going to put a 2 in front of moles of H2O. This is one of those things that's actually so simple that it becomes difficult because you're like, well, it can't just be that. Yeah, it is just that. So we got 24.6 times 2. I don't trust my brain today. That gives me 49.2 moles of water.
Why did you say we didn't know the amount of moles for H2O when we know the 9 moles of H2O?
Well, we know the relationship that there's 2 moles of H2O for every 1 mole of oxygen that we start with.
Oh, okay, I see.
But in this particular instance, we don't know how much water was formed. Mm-hmm.
Yeah, we didn't do anything with the zero.
Pardon me?
We don't do anything with the two.
No, we don't have to do anything with the hydrogen. So the beauty of how this works is we don't have to do a whole bunch of steps. In the chemical equation, we get a whole bunch of different conversion factors that we could make. We can go from oxygen to water, we can go from oxygen to hydrogen, we can go from hydrogen to oxygen, hydrogen to water, water to hydrogen, water to oxygen, etc. It's like get dizzy after a while. So we never have to do multiple steps of moles to moles to moles to moles. It's always one step. Everybody okay?